Hello friends, welcome to Shiksharthi. In this video, we shall be discussing arithmetic series. So let's start. Now under the head of arithmetic series, we are going to basically talk about the introduction. Now when I say introduction, we are going to talk about how is an arithmetic series formed first. Second, what are the ingredients of an arithmetic series? I mean, what do we use? Do we use constant terms only, or do we use variables, or we have a combination of both constant terms and variable terms? Okay. Now when I say arithmetic series, the name itself says that most of the times you will see that we'll be using operators like plus and minus only. I repeat, an arithmetic series, you will see that the series is basically formed with the help of a comma in between. We'll just write down a series so that you are able to understand it in a better manner. But henceforth, when you take it to a next level, you'll be most of the times be using arithmetic operators. So when I say arithmetic operators, I basically mean to say that we'll be using operators like addition and subtraction. The operators plus and minus is what we're going to use. Later on, we can say that plus can be changed into multiplication and minus can be changed to division. Okay. Now, if I write down a series, let's say, so I'm going to write down a series. Let's say that I'm writing terms as, let's say I'm writing a series as 1, 3, 5, 7, 9. Okay. So this is a series that I have already written here. Why do I call this as a series? I call this as a series because I am using real numbers. I'm using numbers. Now whether I use numbers, real numbers or imaginary numbers is not the point of contention. The point here is that you're using numbers, you're using number values, and in between you're using punctuation mark, and that is comma is what you're using here. Okay. And this is the first step for a series. Second is, now the first term and the second term, there would be a logical connect between them. And not only a logical, there would be some analytical connect between it. So, and the same connect which you have between the first term and the second term, the same connect you will have between the second and the third and the fourth and the fifth, and so on. You'll have the same connect. Now when I say this, what I mean to say basically is, now here I have 1 plus 2 is equal to 3, then 3 plus 2 is equal to 5. So the connect here is, you are adding 2 to each of the term to get the subsequent term. For example, when you add 2 to the first term, you get the second term. When you add 2 to the second term, you get the third term. When you add 2 to the third term, you get the fourth term. This is how you'll be getting the subsequent terms also. So there is a logical or an analytical connect between the subsequent terms that you're using, and the connect here is you're adding 2 to each of the term to get the next term. Okay, so here we call it as the common difference. So let's see how we discuss this. So let's put it like this, that here we say that this is the first term. T here symbolizes term. So for further discussions, whenever we are using the term T, that means you're talking about the term. This is the first term, this is the second term, this is the third term, this is the fourth term, and this is the fifth term that we have used here, term. So now when we have already used the terms here, and you know now what? So the first thing that I can write here is, can I say the second term minus the first term? The second term minus the first term is the same as the third term minus the second term, is the same as the fourth term minus the third term, is the same as the fifth term minus the fourth term, which we call it as the common difference. Now, that something that is common that we were talking about, there would be a common connect between each subsequent term. That common connect is known as the common difference. I hope you have understood this. Okay, now in that case, can I say if the first term let's say if the first term is equal to A, then the second term becomes how much? A plus D. The third term becomes what? The second term plus D. The fourth term becomes what? The third term plus D. Here you could have said this is nothing but the first term plus D, and so on. This is what you can say. Okay, now once you have said this, taking this further, you can say if the first term is A. So this was the first discussion. Let's say this is the second discussion now. If the first term is A, then the second term is A plus D. The third term here is A plus 2D. The fourth term here is A plus 3D. And to write this in a proper manner now, so can I say the first term I could have written it as, now this could have been written as A plus 0D. So from here you can extrapolate and you can say the nth term. Now the moment I use the word nth, I am basically talking about the last term. For example, when I say the fifth term, fourth term, third term, second term, we are basically referring to ordinals, we are referring to positions. And why are these all called as terms? Because we are talking about a series which has a common connect, and the common connect here is the common difference, which is why we call this as arithmetic series. It is not any other series. Though we can talk about non-arithmetic series also, but here we are only talking about arithmetic series. Okay, so the last term is something which is called as the nth term, is given by, you can deduce it yourself. So the first term you wrote it as A plus 0D, right? The second term you wrote it as A plus 1D, let's say. The third term is A plus 2D. So you will see the fourth term is A plus 3D. So the nth term by default should be A plus, and whatever subscript you are writing here, the multiple of D would be 1 lesser than that. So if I am writing n here I will be writing it as n minus 1 times the multiple of D. This is how you get the formula for the nth term of an arithmetic series. Now you can apply the same formula and you will get the same. For example, if I want to find out the second term, I'll say what? A plus D. And just a few minutes back we wrote second term as this. So the moment the formula is written like this, we'll be able to say it is arithmetic series. And the moment I say these are various terms, then we will conclude what? These are the terms of an arithmetic series only. So I am giving you a kind of mathematical reasoning. If A holds, then B, and at the same time if B holds, then A, then it becomes a complete theory. In short, when a statement is written, a conditional statement is written, and at the same time you are talking about the converse of that statement, that means it becomes a theory. If the converse also holds good, then you call it as a theory, is what we are talking about. So we talked about now what is A here. A is assumed to be the first term, and what is D here? D is supposed to be the common difference. The last thing that I would like to talk about when we are introducing the numbers here. So we took this series as 1, 3, 5, 7, 9. Here I'll say what? The first term was 1, which is just like saying A is equal to 1. And what is the common difference here? The common difference here is 2. Right? Please mark the words being used, first term and the common difference. Now, the second thing that arises after this, let's say point number 3 is what we are going to discuss here, is what is the limitation of terms? If you would recollect the very first statement that I had made, can we use only constant terms in an arithmetic series? Can we use variables as well? We can use variables as well, but since we are talking about the first point of connect, since we are introducing the topic, so we will be only focusing on the numbers, the constants that we are using. The number values is what we are going to focus on, irrespective of the fact that the number value, or considering the fact that the number value may be a real number value or it may be a non-real number value, which is an imaginary value. Okay, third point here is, so let's say I'm writing few series here. So let us say I'm writing a series as 0, 0, 0, 0. The second series that I have written here is, let's say 0, comma 2, comma 4, comma 6, comma 8. Third, I am writing it here as, let's say 0, comma minus 2, let's say minus 4, minus 6, okay. And the fourth, let's say I am writing here as, so maybe I'll write down more of it, but let us first try and understand what are we trying to do. And instead of using this, we'll be using, let's say this is the first discussion, this is the second discussion, third discussion, and the fourth discussion, so that you don't tend to confuse between A, B, C, D. So can I say the first term here in this series is A, which is equal to 0. What is the common difference here? 0. So the first type of arithmetic series that I am talking about here is, I am basically talking about the first type means what? I can take the common difference as 0 and I can take the first term also as 0. Okay. Now, here, let me just remove this 0 so that you are able to understand this in a better manner. So now in this case, I am taking the first term, let's say this is A, so the first term here is 2. What is the common difference here? The common difference is 2. So can I say here the first term is positive and the common difference also is positive? In this case, the first term was 0 and the common difference was a 0. Let's talk about this case. I am removing a 0 from here. Okay. Now, what is the first term here? Let's say T1 is the first term, is A is equal to minus 2. What is the common difference here? This minus this, which gives us minus 2. So can I say both the first term as well as the common difference, both of them were a 0? Fourth case. So now let me take 2 followed by a 0 followed by a minus 2 followed by a minus 4. So what is the first term in this case? The first term is a 2, which I can take it as A. What is the common difference? The common difference here is minus 2. So can I say this is another kind of an arithmetic series wherein the first term was positive and the common difference here is what? Negative. Okay. The fifth case that I am taking here is, let's say I take the first term as minus 2. Okay. Then the next one becomes 0, then 2, then 4, then 6. Now here the first term, let's say is A, which is equal to a minus 2. And how much is the common difference here? Common difference here is plus 2. Okay. So can I say this is another case wherein the first term is negative, but the common difference is greater than 0. So what was the objective behind discussing this? The objective here is, if I talk about non-zero terms, so basically if I talk about non-zero terms, I can say that arithmetic series can be formed in 4 different ways. What are these 4 different ways? You can have the first term as positive and the common difference thereafter will also be positive. You can say that the first term may be positive but the common difference is negative. The first term itself may be negative along with the common difference being negative, or the first term may be negative along with the common difference being positive. These are the 4 non-zero discussions that I have done. Non-zero means none of these are equal to a 0, neither the first term nor the common difference. Now talking about they being equal to a 0, in that case I can take either A is equal to 0 along with D is equal to 0, or I can take a case like, let us say I took the first term as a 0, second term as 1, 2, 3, 4. Let's say I am talking about whole number series, whole numbers. And the best example that you could have taken here is, here we took the example of even numbers, though we could have taken an example of natural numbers also. Okay. So now when I take the set of whole numbers, can I say this is a series, arithmetic series only, wherein the first term is a 0 and the common difference is positive? And can I take a series like wherein the first term is 0, second term minus 1, minus 2, minus 3? So these basically I am referring to non-negative integers. No, non-positive integers. So when I am referring to non-positive integers, I am basically talking about arithmetic series only. Now in this case, you will say what? The first term is equal to a 0. The common difference is equal to a -1, which is just like saying A is equal to 0 and D is negative. Is there a possibility that you are taking the first term as a non-zero term, but D is what? Let's say D is 0. Okay. But before that, can I talk about non-negative? So if I talk about non-negative, so non-negative, basically what am I referring to? I am referring to 0 and positive. In that case, I am talking about non-negative. So non-negative is nothing but saying what? Whole numbers. They are nothing but the same. Okay. Now what I was talking about is, let us say I take the first term as, I want to take D as 0. So in that case, I can take the first term as 0, or I can take the first term as non-negative. I mean non-zero. So if I take the first term as 0 and this, so let's say first term is 1, second term is 1. So can I say this is an arithmetic series? Of course it is. How? So can I say this becomes a case like last case? Can I take a series like -1, -1, -1, -1? So here what are we saying? We are saying A is equal to -1 and D is equal to a 0. So can we say here A is negative and D is neither negative nor positive, which means it is equal to a 0. So how many cases have we discussed? Let's say we had 5 cases here. This is the 6th case. This is, can I say this is the 7th case? Can I say this is the 8th case? And this we can say is the 9th case. And how did we get these 9 cases? These 9 cases we could have reasoned out also easily, because this is just like saying, now once we have all the cases before us, we could have said we have now arithmetic series is formed because of A and D only, with the help of mathematical operators in between. The mathematical operator could have been a plus or could have been a minus, is what we discussed at the very beginning. So we have only 2 terms, basically two ingredients would be the better word. So we have basically 2 ingredients when we are talking about an arithmetic series, or when we talk about the terms, how are the terms in an arithmetic series formed. Those 2 terms are the first term and those 2 ingredients are the first term that we take A, and then the common difference in between. Okay, so now A could have taken either 0 or positive or negative value, is what we had taken in all these cases, and at the same time D could have also taken either a positive, negative or 0. So this is just like saying 3 into 3, 9 cases are the cases how which different types of arithmetic series can be formed with the help of different values of A and D, using a mathematical operator like plus in between. Because when we are taking the mathematical operator plus here is an unbiased operator. The reason here is the moment you take the value of D as negative, this itself gets fine-tuned to A minus D. Hope you learnt, or you will learn a lot from this video, and this will give you a greater insight, because here we are talking about the introduction, which needs to be very clear for you to go ahead in detail. Now our subsequent videos will talk about the properties and many other characteristic properties of the arithmetic series. If you feel that this video was really informative, please do not forget to like, share and subscribe to our channel. If you have already done, click on the bell icon and select all, so that you get updates from us regularly. If you want us to do videos on specific topics, please don't hesitate and put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.